What's up guys, today we'll be doing Catholic High School Prelim examination for 2024, Paper 1 Booklet B. I will not be going through every single question, only those that I feel are challenging. Alright, let's get started. We are looking at question number 19. It says find the value of 10w over 5 minus w plus 1. Okay, and it says when w equals to 4. So what I want to do is to replace my w with 4. Alright, so I would have 10 times 4 divided by 5 minus 4 plus 1. Alright, we know that 10 times 4, that would give me 40 divided by 5 minus 4 plus 1. Alright, moving right up here. 40 divided by 5, that would give me 8. So I would be left with 8 minus 4 plus 1. And that would simply give me 5. And this is your answer for question number 19. Moving on to question number 21, let's read the question together. It says, use all the digits 6508 to form part A, the greatest multiple of 5. First thing I want to understand is that a multiple of 5 will always end with 5 or 0. Alright, it will not end with any other number. From here, I immediately know that my number will either end with 5 or 0. Now, moving on to the next part, I want to divert our attention to this word greatest over here. Whenever I see this word greatest, right, I don't want to waste my big numbers on the smaller places. Let me explain. Alright, for a 4-digit number, we have the thousands place, we have the hundreds place, we have the tens place, and lastly, we have the ones place. What do I mean when I say I don't want to waste my big digits on the smaller places? Alright, imagine I put my 8 over here. Alright, when it can potentially be in my thousands place, that will make my number very small, because if my 8 is in the ones place, the next biggest can only be 6. Right, and it will be 6,000 when it potentially can be 8,000. So moving on from here, what I don't want to do is to put my 5 over here, right, at the end of it. What I want to do is to put my 0, because my 5 can be used elsewhere. And what I want to do from here is to definitely put my biggest number in the thousands place first, which is 8. And the second biggest in the hundreds place. And lastly, the third biggest in my tens place. And this is your answer for question 21, part A. Alright, 8,650. Moving on to part B, the question wants us to form the number closest to 6,000. So what they are looking for is the numbers closest to 6,000. So definitely what I want to do is to start with 6. Right? Having a 4-digit number, I want to start with 6. Alright? And if I were to put any big numbers over here, right, it will be actually further away from 6,000. So I want to keep it as close as possible by putting 0. You realize that 6,000 starts with 6 and 0 as well. 6 and 0, 6 and 0. Alright? And then from there, what I want to do is to put the smallest number first, followed by the biggest number. Alright, so it will be 6,058. And this is your answer for part B. Moving on to question number 22. Jessie had a total of 30, 20 cents and 10 cent coins. Alright, this is sentence number 1. Now, we don't know how many 20 cents she has. We also don't know how many 10 cents she has. Alright, moving on to the next sentence. It says she exchanged all the 10 cent coins for 20 cent coins and had a total of 17 20 cents coins after the exchange. If she had a total of 17 20 cent coins, what I can do is to find the total amount of money that she has. Alright, and that would just be 20 cents times 17. And that would just give me $3.40. Knowing that her total was $3.40 and she had 30 coins, what I can use, right, is to apply this concept called guess and check. Alright, whenever I use guess and check, what I want to do is to draw myself a table. Okay, so she had 20 cents and she had 10 cents. And this will be our total. So our total will have to meet with the $3.40 criteria before we get it right. What I want to do is to first guess, alright, the number of 20 cents and the number of 10 cents, but they must add up to 30. So what I'm going to do is to start 15 and 15 first. And what I'm going to do is to write the value of 15 20 cents and 15 10 cents. What I want to do is to write the value of 15 20 cents beside over here and the value of 15 10 cents over here, and add those two numbers up to see if my total reaches $3.40. Alright, so 15 20 cents would give me $3. 15 10 cents would actually give me $1.50. Right, adding these two up, we notice that our total is $4.50. So this is definitely not my answer. Alright, I realize that my answer is too high. So what I want to do is to reduce my 20 cents so that my 10 cents can increase and therefore bring the total amount lower. Alright, so now since I have too many 20 cents, right, what I want to do is to maybe bring it down to 10. 10 20 cents would give me $2. And what I would be left with is 20 10 cents. And 20 10 cents would give me $2 as well. Alright. Now adding these two up, you see that I still have a value of $4. So this is still not my answer. Alright, I need to bring it lower. What I want to try next is 5 20 cents and 25 10 cents. We know that 5 20 cents will give me $1. 25 10 cents would give me $2.50. Adding these two up, you see that we will have the total of $3.50, which is just 10 cents off away from the total that we need. Alright, so what I want to do is to bring it down to 4. Right, 4 20 cents. Right, 4 20 cents, that will give me 80 cents. And what I will be left with is 26 10 cents. 26 10 cents would give me $2.60. Adding 80 cents and $2.60 would give me $3.40. And we know now that this is the combination of 10 cents and 20 cents that Jessie has. Alright, let's move on to the last sentence. Let's see. It asks, how many 10-cent coins did she have at first? Alright, so looking at the 10-cent coin column, we can see that the amount of 10 cents that she has at first is 26. And this is my answer for question number 22. Moving on to question number 23. Reading the question, it says, find the area of the shaded triangle. Okay, right over here, I can immediately tell that this is an area question. And this triangle given to us is something we like to call a slanted triangle. Whenever I'm faced with a slanted triangle, what I want to do is to identify the height first. Alright, the height of a slanted triangle is definitely not this. Neither is it this. What we need to understand is that the height of the triangle is the vertical height from its base, which is right over here. So 15 cm is the height. Now for the base, right? It is very tempting to just say, oh, the base is 42 cm. But that is not true. Alright, if you realize the base starts from here all the way to over here, right? And that is not what 42 is. To find our base, what we want to do is to take 42, which is the length of the whole figure, subtract away the 10 cm, and that will give me 32 cm. And this is my base. Alright, so now I have my base of 32 cm and my height of 15 cm. Applying my formula to find the area of a triangle, which is area of triangle equals to half times base times height. Substituting my base and my height with the numbers we found, we have half times 32 times 15 cm. What does this give us? This gives us 240 centimeters square. And this is your answer for question number 23. Jumping right into question number 24, let's read the question. A rhombus ABCD is on a square grid. Alright, let's look at part A. It says, using the line RS, draw a square PQRS such that it has the same perimeter as ABCD. Alright, first thing I want to do, I want to look at ABCD. Okay, knowing that ABCD is a rhombus, I know for sure that every side of my rhombus is the same. So I'm just going to pay attention to one side of the rhombus. So whenever we are met with a square grid kind of question, alright, I want to count the vertical jumps and the horizontal jumps to measure my lines. Alright, so from C I have 1, 2, 3 verticals and 2 horizontals. That leads me to B. Alright, so I know that my line will always be 3:2. Now looking at line RS, what I want to do is to form my square over here. So what I want to do is to apply the 3 and 2 bounces to find where my lines will be in my square. Alright, starting from R, I have 1, 2, 3, 1, 2. So what I know is one point of my square will be here. Let's look at S right now. I have 1, 2, 3, 1, 2. And I know that the other point will be here. And now if I were to just connect the dots to form my square, you realize that I will have a perfect square. And this would be my square PQRS. Alright, moving on to part B. It says, what fraction of the area of rhombus ABCD is the area of square PQRS? When we are faced with a question like this, I want to bring your attention to two words that are very important. Alright, the first one being of. When we see this word of, we know that the area that follows after is definitely the denominator. And when we see the word is, we know that the area that follows after will definitely be the numerator. Now I want to take a look at my rhombus ABCD. It would be difficult to use our formulas to find the area of the rhombus and my square because we do not have the lengths given to us. But what I want to show you is that we can break the rhombus up into squares. Alright, they have given us a square grid. First, what I want to do is to look at my rhombus and count the number of whole squares I have in my rhombus. If I were to look at it, I have 1, 2, 3, 4 whole squares over here. Alright, now looking at the rest of it, we see that they are broken. What I want you all to notice is that actually there is a small triangle over here and a square without a small triangle. So if I were to put this small triangle into this corner, it actually forms one whole square. Okay, likewise with this part over here, down here as well, and here as well. Alright, so apart from the 4 holes we have 5, 6, 7, 8 more squares. And now if you notice, I have one triangle here and a part that is missing the same triangle. So if I were to move this triangle over here, you realize that I have a full square as well. Alright, so I want to count the number of extra squares that I have. Looking at this, I know that I will have another 9, 10, 11, 12. So what I can say is that my rhombus has 12 squares. Now moving on to square PQRS, I want to count the number of whole squares I have inside as well. So I would have 1, 2, 3, 4 and 5 over here. And then now looking at the rest of the parts, what I want to do is the exact same thing I did with my rhombus, right? Which is to count the number of parts that adds up to a whole square. Alright, so I have 1 over there, 2, 3, 4. Alright, and you realize that the others work as well. I'll have 5, 6, 7, and 8. Alright, so looking at this, I know that I have 6, 7, 8, 9, 10, 11, 12, and 13. So my square PQRS has a total of 13 squares. Alright, knowing this, what I want to do, right, is just to form my fraction. Alright, knowing the denominator is my rhombus, definitely I'll put the 12 below. My numerator has to be the square, which is 13. And what we don't want to do is to leave it in an improper fraction. So what I want to do is to change it to a mixed number. And that would give me 1 over 12. And this is my answer for part B. Moving on to question number 25. Alright, let's get started. In 1 minute, machine A can pack 5 boxes of cookies, while machine B can pack 2 boxes of cookies. Alright, this is sentence number 1. I want to list down the information that is given to me. So I have machine A packing 5 boxes per minute and machine B packing 2 boxes per minute. Let's move on to the next sentence, sentence number 2. It says both machines started packing at 12:50 a.m. So I know the start time is 12:50 a.m. If both machines started at the same time and A produces 5 boxes per minute and B produces 2 boxes a minute, in 1 minute, both A and B would produce a total of 7 boxes per minute. Now let's look at the next sentence. It says, at what time will both machines pack 175 boxes of cookies in total? And the question asks us to leave our answer in 24-hour clock. Alright, so this is obviously a time question. Alright, and when I am faced with a time question, I remember my ABCDs. Alright, and that is to always make it whole, break it up, cancel out, and to draw a timeline. Sentence number 3 asks us what time will both machines pack 175 boxes of cookies in total. Alright, they are looking for 175. How many minutes will it take for 2 machines to have 175? How am I going to find that? I'm going to use the concept of number of sets to find that out. So I have 175. What I want to do is to divide that by 7. Alright, and I'll get an answer of 25. It takes 25 minutes for both machine A and machine B to produce 175 boxes of cookies. Alright, so right now what I want to do is to draw my timeline. Alright, I know it starts at 12:50 a.m. and it takes 25 minutes. So the whole thing will take 25 minutes. But what do I want to do? I want to break it up. So what I want to do with my 25 minutes is to break it up to 10 minutes and 15 minutes. Why? Because I know that my start time is 12:50. So I want to use the first 10 minutes to make it whole. Alright? And that would be 1 a.m. The first 10 minutes will bring me to 1 a.m. And then lastly, what I'm left with is 15 minutes. Alright, and that would definitely give me 1:15 a.m. Now the last sentence of the question says to leave your answer in 24-hour clock. So what I'm going to do is to change 1:15 a.m. to 24-hour clock, which will be 0115. And this is your answer for question number 25. Moving on to question number 26. Let's jump right in. The airmail rates to a country are shown in the table below. Alright, the first 20 grams, we don't know how many cents that costs. But every additional 10 grams or less, we have to pay 12 cents. Alright, Quinton sent a letter that weighed 33 grams. Alright, this is my sentence number 1. I want to pay attention to the total weight. The weight of his letter is 33 grams. Moving on to sentence number 2, it says that he paid 56 cents for it. Okay, so this 33 grams cost 56 cents. The question asks us, how much did Quinton pay for the first 20 grams of the latter? Alright, so 33 grams. First, I want to split this 33 grams into the first 20 grams and 10 grams or less thereafter. Alright, so I have 33 grams. What I want to do is to just break it up. 33 grams. I want to split it up into 20 grams, 10 grams, and lastly 3 grams. The information from the table tells me that every additional 10 gram or less thereafter from the first 20 grams is an additional 12 cents. Alright, so what I want to do, right, knowing that he paid a total of 56 cents for 33 grams, what I want to do is to find out how many cents he paid for 20 grams. How can I do that? What I need to do is to take 56 cents minus 12 cents minus 12 cents, and that will give me the amount for the first 20 gram, and this would give me 32 cents, and this is your answer for question number 26. Let's move on to question number 27. Gregory glued 9 unit cubes together to form the solid shown. Right, A tells us draw the top view on the grid. Alright, so looking at this figure, what I want to do is to visualize it from the top and to shade just the faces that are exposed from the top view. Alright, so every top of the cube, I want to shade. Okay, and this is how many squares I will have on my grid over here. Alright, so looking at this, I know that I will have 6 cubes on my grid. Alright, what I want to do is to start from this cube right over here. Okay, what I want to do is to just draw that one cube first. And then you notice that there is one directly beside it. So I'll draw that next one. And then moving down from the top view, there's another beside it, but one more at the bottom. Right? And then following up after that, you have 2 more at the side, but at a lower step. But the ups and downs don't matter. Right? Because we are looking at it from top down. Alright, so this is your answer for part A. Moving on to part B. Gregory glued more unit cubes to the above solid to form a cube. This is sentence number 1. What was the least number of unit cubes used by Gary? I want to divert our attention to this word over here. If we are looking for the least number of unit cubes used by Gregory, what I don't want to do is to make the longest length in the figure even longer. What I want to do is to find the longest length and make that the length of my cube. Looking at the figure, I can see that the longest length currently is this one over here, being 4 unit cubes long. Alright, so I know that my cube will definitely be 4 by 4 by 4 unit cubes. Alright, and that will give me a total of 64 unit cubes. Knowing that my cube requires 64 unit cubes, what I can do is just to subtract the existing 9 unit cubes and to get my answer. So that would just be 64 minus 9, and that would give me 55. And this is your answer for question number 27, part B. Moving on to question number 28. 40 pupils helped to sell packets of popcorn at a school carnival. So I know the total number of pupils is 40. Moving on to the next sentence, it says each pupil was given 6 packets of popcorn to sell. Right? If each of them are to sell 6 packets of popcorn, what is the total number of packets? Total number of packets would just be 40 pupils multiplied by 6 packets each, right? And that would give me 240 packets. Moving on to the next sentence, it says, some pupils did not turn up. So each pupil present had to sell 2 more packets of popcorn to meet the required sales. Okay, I am guessing that the required sale is to sell a total of 240 packets. When some of the pupils did not show up, those who went had to sell 2 more packets of popcorn. 2 packets is actually 1/3 of the original 6 packets that they were supposed to sell. What this means is that for every 1 pupil that did not show up, 3 other pupils had to split the 6 into 3 twos. From this, we can tell that the ratio of pupils who showed up to the pupils who did not show up is 3:1. Right? For every 1 pupil that did not show up, he needs to split his 6 packets into 3, giving 2 each to 3 students who actually showed up. Alright, and knowing that the total number of pupils is 40 and that I have a total of 4 units over here, what I want to say is that 4 units equals to 40 pupils. And 1 unit equals to 10 pupils. Now let's look at the question. The question asks how many pupils did not turn up. Knowing that the number of units for pupils not showing up is 1. Alright, there you have our answer over here. 1 unit equals to 10 pupils. And this is my answer for question number 28. Moving on to question number 29. A box contains beads of 3 different colors. Alright, this is my sentence number 1. So we know there are 3 colors of beads. Now, sentence number 2 says, 3/5 of the beads are red, and the rest are blue beads and green beads. When I'm faced with such a sentence, what I want to do is to draw a model, right, to help me to visualize things better. And I know that 3/5 of it is red, and then the rest are blue beads and green beads. Now let's look at sentence number 3. It says the ratio of the number of blue beads to that of green beads is 2:3. So I know the ratio of blue is to green is 2:3. But if you notice, my model only has 2 units left. But the total number of parts in my ratio, right, is 5. So what I want to do is actually to find a common multiple. And I can find that by just multiplying the number of units and the number of parts. Alright, so I will have 10 units over here, and of course 10 parts over here by multiplying it by 2. Alright, so multiply by 2, multiply by 2. That will give me 4:6. So I know now that 4 units over here is blue, and the remaining 6 units are green. What I did to my 2 units in blue and green, I want to do to the 3 units in red as well. So now in total, I have 25 units. And let's look at the question. What does the question say? What percentage of the beads is blue? So I know that blue has 4 units right now. So the fraction of blue units is 4:25. And how can I find the percentage? I'm just gonna multiply it by 100%, and that would give me 16%. And this is your answer for question number 29. Alright, let's look at question number 30, the last question of booklet B. A baker had a number of cakes for sale. This sentence doesn't give us much information. Let's move on to the next sentence. It says, after selling 42 cakes in the morning, from this we know that in the morning, the bakery sold 42 cakes. And 4/9 of the remainder in the afternoon. So in the afternoon, we know that the baker sold another 4/9 of the remainder. Moving on to the next part, it says it was left with 1/3 of the cakes. Now what I want to do is to draw a model, right, to help me to visualize it. I have my bar model over here. I know that 42 was sold in the morning. And then what happened to the rest? 4/9. So I'm going to split this up into 9 units. Now that I've split it up into 9 units, what I want to do is to label that 4 units is sold in the afternoon. Alright, and the rest of it is 1/3 of the total. Okay, knowing that this is 4 over 9. And this over here is 5 over 9. What I want to do now is to take my 1/3 over here and divide it into 5 so that I can find what this 1 unit is in relation to the total number of cakes being sold. Alright, so I have 1 over 3 divided by 5. That would give me 5 over 1. And what I do, I want to change my sign to multiplication and flip the sign. And that would give me 1 over 15. Now I know that my 1 unit over here is 1 over 15th of the total cakes being sold. Alright, and what I want to do now is to multiply it by 9 because I have 9 such units. So I'm going to take 1 over 15 multiplied by 9, which is also 9 over 1. What I'm going to do is take the numerator multiplied by the numerator and the denominator multiplied by the denominator. And that would give me 9 over 15, which is equals to 3 over 5. Now what I know is that the entire thing over here is 3 over 5 of the total. And what is over here is definitely what is left of this 3 over 5, which is 2 over 5. Alright, knowing that 2 units equals to 42, I want to find my Mr. Green Man, right, which is 1 unit, which is just 42 divided by 2, and that will give me 21. Alright, now what I want to do is to find the total, which is 5 units, and that would give me 21 times 5, and that would be 105. Now they are asking us to find how many cakes were left, which is 1/3 of the total. So moving up here, if my total equals to 105, 1/3 will be equals to 105 divided by 3. And that would give me 35. And this is your answer for question number 30.
Hi everyone, if you like this video, you can click right here for a similar video or you can view our playlist here.